Hello, everyone, and thank you for joining us today for the webinar on the title Importance of Titrimetric Determination of Hardness and Alkalinity in the Water Industry. Webinar is presented by Mr. Omkar Pendarkar. And before we start, I would like to announce that we will be sending a recorded webinar link after the webinar. You may ask questions in the Q&A panel at the end, and you will have 10 minutes for the question and answer round. Allow me to introduce our presenter today, Mr. Omkar Pendharkar. Omkar is a product specialist and completed Masters in Organic Chemistry from Mumbai University. Omkar is having more than 2 years of experience in titrators. With that, over to you, Omkar.
Thank you for the introduction. So we will see the importance of titrimetric determination of hardness and alkalinity in the water quality and water industry. So just confirm. Let me share the screen. Is my screen visible to all of you?
Yes, it's visible.
Okay. So today we are going to see the importance of determination of hardness and alkalinity of water in water industries. So in water treatment plants and water quality measurements, hardness and alkalinity are the key parameters which can affect the water quality for industrial water as well as the household water. So we will see the concept of hardness and alkalinity, the main reasons or the causes for the alkalinity and hardness, and the effect of these parameters. So basically, hardness of the water is the amount of mineral content present in the water. It is generally a measurement of divalent cations. So when the water flows through rivers, streams, or any other water resources, water absorbs mineral contents from rocks and soil, and after that they reach to the water supply. This is the main reason for the presence of hardness of the water. So the ions present in rocks and soils contribute to the total hardness of the water. Then these are the main reasons of the hardness formation in the water. So hardness is basically, we have seen that hardness is basically measurement of divalent cations present in the water. So basically these divalent ion contains calcium ions and magnesium ions. Hard water, hard water is formed when the water flows through deposits of limestones, chalks, or gypsums, which are largely made up of calcium and magnesium in form of carbonates, bicarbonates, chlorides, and sulfates. So when we measure the hardness of water, that contributes to the measurement of calcium ions and magnesium ions present in the water. There are also some extra factors are there which causes the hardness of water, but they are in negligible amount. Uh, um, they are in the negligible amount than that of the calcium and magnesium. So there are different types of methods which can be used for the determination of hardness. So the basic hardness is determined in the milligram per liter or ppm unit. The water is considered as hard water when this ppm limit exceeds the limit of 120 ppm. So there is a poll for all of you. Uh, just answer the question. You have the time of 30 seconds. You can answer this question in 30 seconds. So the question is, which water is considered as more hard water, The options are rainwater. Second option is groundwater. 5 seconds are remaining. Okay, so I'm going to publish the results. So all of you have given the right answer. The groundwater is considered as more hard water because it contains the dissolved salts of calcium and magnesium. Basically, the rainwater does not flow through any types of rocks or soils. So it is considered as more pure water or less hard water than that of the groundwater, because in groundwater there are different types of minerals and ions are present, which causes the hardness of water. So these are the main reasons for the hard water. Now we will see the effects of water hardness in the water industry, water treatment plants, as well as in household water. So the first and most important effect of the hard water is the scaling. So scaling is the biggest problem caused by the hardness. Calcium and magnesium carbonates have the tendency to deposit as off-white or the brownish solids inside the surfaces of pipes. So this process is known as the scaling process. So after a period of time, this scaling can lead to the plumbing issues such as low water pressure, clogging in the pipes, and appliances, which contribute to the loss of efficiency and premature breakdowns. So it will also increase the maintenance cost for your appliances and your treatment systems. So you have to replace the uh, pipes or the industrial systems due to the clogging inside caused by the hardness of water. So the second important effect is residues on appliances and kitchenware. This is the effect of hard water in the households. So hard water results into white spots or residues on the kitchenwares, utensils, dishes, etc. So they have to replace more frequently than that of the normal water. So this results into the maintenance issues in appliances like dishwashers, washing machines, etc. So this hard water in household can affect the staining on the utensils, the kitchenwares, as well as we can see the brownish or yellowish staining in the bathroom or the flooring of the house. So this is also caused by the hardness of water. The next effect of water hardness is on the uh, clothes. So calcium and magnesium in hard water form salts which get precipitated with the soap. So hard water does not form any foam with the soaps. So when we clean the clothes by using the soap, there is formation of precipitate of calcium and magnesium salts with soap. So that affects the cleaning procedure of clothes. The same thing can happen to our body when we use the soaps for the bathing purpose. That hard water can form the precipitate with the soap, which will not completely remove the dirt on our body. So in case of clothes, by using the hard water for cleaning, it the hard water makes the clothes stiff and weak, so it reduces the lifespan of the clothes. Along with these effects, there are some health hazards caused due to the hard water. So, as we seen earlier, hard water does not react with the soap. It forms a precipitate rather than the foam. So it causes the dry skin and dry hair. The hairs cannot be feel like the silky hairs. So it may be feel like the soap is getting washed with the water, but instead of getting washed off, the soap reacts with the hard water, so it cannot be removed completely from the body. So left behind soap can absorb the moisture and oils directly from the skin to make it dry. So in the health hazards, the main effects are seen on the skin and hair. Along with this, some digestive issues can also be observed, as the minerals can react with stomach acid that can cause the discomfort or indigestion. So these are the health hazards that can be caused by the hardness of water. So this was the concept for hard water. We have seen what is the meaning of hard water, how it is determined, the reasons for the presence of hard water, as well as the effects that can be caused by the hardness of water in industrial as well as household uses. Then we will see the concept of alkalinity of water. So alkalinity of water is generally defined as it is a measurement of capacity of water to neutralize the acids. So alkalinity means presence of some basic chemicals or some components which can cause uh, the higher pH of water. uh, it is called as the alkalinity of the water. We will see the causes of alkalinity. These are the some general reasons for the formation of alkalinity in the water. Presence of bicarbonates from the partitioning or separation of carbon dioxide from the atmosphere. This can cause the higher pH values in the water, as well as the weathering of carbonate minerals in rocks and soils. Weathering is basically breaking down or the dissolution of rocks and minerals on the earth's surface. When the water flows through the earth's surfaces, some minerals from the rocks and soils can get dissolved in the water in form of carbonates and bicarbonates, uh, which can make the water alkaline. This is the major reason for the uh, formation of alkalinity in the groundwater. Along with this, some salts of weak acids such as borates, silicates, ammonia, phosphates, and organic bases from natural organic matter can also cause the alkalinity. These are some effects on the industrial water as well as the household used water. So basically, just like the hardness of water, the main and important effect of alkaline water is the scaling. So when water with high alkalinity is used in boilers, coolers, or any industrial systems, it can lead to formation of scaling on the internal surfaces. So in case of boilers and coolers, alkalinity is a key control parameter for boilers and coolers. If alkalinity exceeds the prescribed range, then it can lead to corrosion, caustic metal embrittlement, carryover, and scaling inside the pipe surfaces. This uh, this is the main and important factor for the effect of alkalinity of water, and this scaling can also lead to our next effect, overheating of heat exchangers. So this scaling can reduce the heat transfer efficiency, and this inefficiency in the heat transfer can lead to overheating, which can cause the damage to the boiler. So maintaining the proper alkalinity for boiling boiler water or cooler water is important for the safe operations of the water treatment plant. The next effect of alkalinity of water is corrosion related problems. So we have seen the first two effects are generally caused due to the higher alkaline water. So if the alkalinity of water goes down uh, than the certain limit, then it can cause the corrosion. So that low alkalinity of the water in the water treatment plants can cause the corrosion related problems inside the pipes or the carrying machineries. Then there are some health effects. Generally, we are seeing the trend of drinking alkaline water, but it has a specific limit for the drinking purpose. After that specified limit, that alkaline water can also affect badly on our health. So extensive amount of the alkaline water can cause the digestive issues like stomach pain, nausea, and vomiting. So up to certain limit, the alkaline water is fine, but the extensive amount or extensive alkaline water can cause the health hazards. So now we have seen the concept of alkaline water, the reasons for the alkaline water, and the effects in the industrial as well as home applications. So now we will come to the determination part of these key parameters. So we have seen the concept for hardness as well as the alkalinity. Now we will see the procedures for the determination of hardness and alkalinity by using titration. So there are different types of methods available which can be used for the determination of hardness, such as photometry is there for the determination. Some reagent test kits are available for the determination of these parameters, and titration is the more accurate and uh, reliable analysis method for the determination of these two parameters. So we will see the instruments which can be used for the determination. So we will see first the titration for hardness of water. So there are titrimetric methods available for the direct determination of hardness of water by using photometric electrode as well as some ion selective electrodes. So hardness of the water can be determined easily and accurately by performing the photometric titration with EDTA solution by using Hanna Titrators with the photometric electrode HI90060. So Hanna titrators can provide direct method for the determination of the hardness of water. So this method has a reference of standard method for the examination of water and wastewater. With reference to this method, we can determine the hardness of water by using titration with EDTA solution. So in this titration, the calcium, the hardness causing ions form the complexes with the EDTA, which is used as a titrant solution. So either by using the photometric electrode or by using the ion selective electrode, we can determine the hardness of water by using the titration method. So there is another titrimetric method for the alkalinity of water. This is also the prescribed method, which is readily available from the Hanna Titrators. So generally, the determination of alkalinity consists of acid-base titration. So it can be determined by the simple acid-base titration with hydrochloric acid by using Hanna titrator and pH electrode. So in case of alkalinity determination, we will use the pH electrode for the analysis. This method has the reference in the standard methods for the examination of water and wastewater 21st edition. So by using this method, we can directly determine the alkalinity of the water sample. So considering the importance of hardness of water and alkalinity of water, it is necessary to keep the both of the parameters in the controlled. So we can monitor these parameters by using titrimetric methods and Hanna titrators. So there are another two questions for the poll. You have the 30 seconds time limit for the Okay, so here comes the second poll. Determination of hardness involves uh, dash dash titration. So your options are acid base titration, complexometric titration, redox titration, and precipitation titration. So you have 30 seconds to answer. Okay, so last 5 seconds are remaining. Fine. So most of you have given the correct answer. That is the complex metric titration. So basically, basically the titration for the hardness of water with ADTA involves the complexometric titration. The calcium and magnesium form the complexes with the ADTA, where ADTA can be used as a complexing agent in this titration. So this is termed as the complexometric titration. Uh, and last poll for you. In alkalinity titration, we will use dash dash as titrate solution. Your options are acid or base. You have 30 seconds to answer. Last 5 seconds are remaining. Okay, so all of you have answered the right answer for this question. So we will use the acid as titrant because we are determining the alkalinity of the solution. So it will involve the acid base reaction where we are titrating the base present in our sample with the acid. So the titrant solution should be the acid. Generally, we use the hydrochloric acid for the determination of alkalinity. So we have seen we can use the Hanna Titrator systems and the electrodes for the determination of hardness as well as the alkalinity. The methods are already created with reference to the standard references for the water and wastewater quality analysis. So along with the titrator, we can make this complete analysis easy and automated by using the auto sampler. So the titrator has the facility to attach the auto sampler for the automated titration. So these are the some features for the auto sampler which can get connected to the titrator directly. So you can automate up to 18 samples. So you just have to take the sample in your beaker, the reagent addition facility, as well as the sample leveling facility is already provided with the auto sampler. So you can analyze 16 to 18 samples in the single run. Then another feature is optical IR beaker detection. So in this auto sampler, an optical IR beam is provided which detects the presence or absence of beakers within the sample tray. So the users can dictate the auto sampler action if a beaker is missing from its position. So the titration can get stopped, skipped, or paused if any beaker is not present in the specific position. So for that, the optical IR beaker detection system is provided. Then in the auto sampler, there are the features for electrode rinsing, sample leveling, and waste removal. So these processes can completely automated. So in between the analysis, the electrode rinsing can be performed automatically by the titrator commanding. So you can create a sequence for the analysis of multiple samples, and these samples can get analyzed uh, in the single run. Sample in case of sample leveling feature, the reagent addition for the particular sample analysis can be done by the autosampler itself. Uh, Along with sample leveling, waste removal feature is also there for the removal of waste solution from your sample beakers. Then the auto sampler has the digital balance compatibility, so you can connect your weighing balance directly to the auto sampler, which can directly record the weights of your samples inside the system and calculate the results directly from the provided weights. So you can make your analysis completely convenient and automated by using auto sampler system provided with the Hanna Titrators. So these are some advantages of using the automated system for the Hanna Titrators. So basically, the first and important advantage is it is simple, convenient, and accurate method for the determination. So the methods used for the determination of hardness and alkalinity and any many other parameters are already created, uh, referring to the standard methods for the analysis. So you can just install those methods in the titrator and you can perform the analysis conveniently than that of the manual titration methods. It can give the better accuracy and reproducibility. So uh, by using the automated system for the analysis of parameters, you will get the more accurate and consistent results than that of the manual titration. Uh, the system completely uses the electrodes and the sensing system for the determination of endpoint. So the results calculated after the titration are more accurate and reproducible than that of the manual titrations. It is time saving and reduced need for the technical skills. In in comparison with manual titration, the automatic titration is more convenient and time saving for the analysis. Also, it will reduce the need of technical skills. In case of manual titration, we need the multiple technical skills for the analysis. The results can vary from person to person due to the difference in the technical skills. That is not the case of potentiometric titrators. So this is also the important factor for the difference in the manual titration and the potentiometric titration. Reduced titrant and reagent usage. So we have seen uh, uh, during the analysis of any sample or any parameter by manual titration, there are so many reagents are used, and due to the manual procedures, most of the reagents can get waste due to the mishandling. And also there is a safety concern for the reagents used for the analysis. So this usage and safety concern is the usage of the reagents can be reduced by using the automated system, and the more safety is provided because we are not handling the chemicals directly. Uh, we are titrating the sample and we are analyzing the parameters by using automated system. Then there is next advantage of the potentiometric data is traceability. So every data you have analyzed or every parameter you have analyzed, it will get automatically stored inside the titrator. You can get the complete data for that titration uh, stored in the instrument, as well as you can see the GLP, that is good laboratory practices, the calibration data saved in the instrument. So your data will be completely traceable, and which can be stored inside the instrument, as well as it can be transferred from instrument to directly PC. So thank you all of you for your attention. We have seen the titrimetric analysis for the hardness of water and the alkalinity of water. If you have any doubts regarding this analysis or the parameters, you can raise your questions in the chat box, as well as our email IDs and the contact numbers are provided on the screen. You can note down, and if you have any queries or doubts regarding any type of titrimetric analysis, you can directly contact us for the more information. So now we will see the question answers. So the first question is by Mohammed sir. What are the limitations of the titrimetric method? So basically, there are some differences in the manual data. Basically, there are some differences in the titration method and some other methods like photometric method or the reagent test kit methods. So in case of titrimetric methods, uh, the most common limitations are the uh, time required for the uh, sample preparation. So there are some parameters which require some extra time to prepare a sample, and then you have to analyze it by using the manual or the potentiometric titration. So this is the basic limitation for the titration. It can take some time or some extra reagents for the preparation of sample, but it will give you the more accurate results, more reliable results than that of the photometry and the reagent test kits. What is the error in the titrimetric analysis? The second question. I hope. Okay. So what is the error in the titrimetric analysis? So there are multiple sources of error in the determination by using the titrimetric analysis. The most important factor is the weight transfer or sample transfer during the analysis. So you have to take care that complete sample is getting transferred for the titration. This can be the main reason for errors caused during the titrimetric analysis. Then there are some different errors there depending upon the technical skills of the analyst. Reagent addition uh, is one of them. So you have to add particular reagent in particular amount for the better results. Okay, then there is question from Narendra sir. What is the difference between titration and titrimetric? Basically, titrimetric is the method of analysis by using the titration. So titrimetric and titration are not any different parameters. They are the same. We are just we are just giving a terminology titrimetric which means the analysis which used and which means the analysis that is done by using the titration. Next question is by Suraj. Does this titrator help us analyze all the parameters required by PCBs, including TDS, COD, BOD? So yes, there are some methods which are pre-generated for the determination of COD, BOD. Uh, so we can use the oxidation reduction titration for the determination of chemical oxygen demand. We can use the potassium dichromate for the determination of COD, and the method is pre-established for the COD. Again, there are many different methods are available for the determination of different types of water quality parameters, which can be done by the potentiometric titration. Okay, so if you have any another question, you can put the question in the chat box. Okay, Mohit sir, we will take it in account. Okay, fine. So thank you all of you for attending the webinar. If you have any further doubts or any queries regarding the webinar, as well as some titrimetric method or titrimetric analysis, you can ask or you can directly contact us on the given contact numbers or the mail IDs.
Omkar, there is one more question asked by Mr. Ketan Desai.
Uh, so Ketan sir has asked, so this COD BOD analysis will be correlation based evaluation. I didn't get your question, sir.
Ketan, Mr. Ketan, you can speak. You can ask your question. Yeah.
Audible?
So can
Am I
you
audible?
elaborate? Yes, you are
Yeah, yeah.
audible. Can you
You
elaborate?
recently mentioned that COD and BOD analysis are also possible with this system. So
Uh-huh.
this analysis will be a correlation-based methodology, or it will be an exactly COD analysis or BOD analysis that has been carried out?
Yes, sir, there is a direct procedure for the determination of COD by using the potentiometric titrator. So we have the method for direct determination for the COD.
Because as of now, like we use COD higher temperatures, like 150 degrees centigrade for some 2 hours of time frame. So like
Yeah.
those facilities are available in the system that you have showed to us.
Yes, sir. Actually, for the digestion process, you have to digest the sample at 150 degrees Celsius for
Okay,
two
okay,
hours.
that has to be done separately, and
Yeah.
then we have to do the titration based
Titrametric.
final.
Yes, yes,
Okay,
yes.
okay, I got it. I got it.
Yeah.
Okay, thank you.
Do you have any more questions?
Okay, so we will end our session here. We will share the recording of this webinar. If you have any further queries, you can directly contact us. Thank you all of you.
Thank you everyone for attending.